Hello, good evening. Hope this finds you well. Back to our programming sessions. Make sure before you watch this episode, you have already watched the previous episode, which included quite a number of aspects that we covered. And this is the brief outline, but more was shared verbally based on the target of that previous episode. So today I want us to look at something as a continuation from where we had ended the previous moment. So all I need is just a new tab here. So we shall begin by asking ourselves a question. Why programming? I know if you had watched the previous episode, you might have had this question, asking yourself, what is the role of programming, or why do people program, or why are programmers in existence? And the answer is a very precise one. Programming is about problem solving. Now, in the world of IT, we seem to have quite a number of problems, and those problems can only be solved by writing programs. So each program or system or an application, like we talked about them in the previous episode, is written to solve a certain problem. So imagine, why are you using Microsoft Word? Because you need to process documents. Imagine, why do you have VCL or whatever the case may be, this here VLC media player? Because you want to play media files, audio and video. So basically, what am I trying to say is that every application is written because there was a problem. Okay, so what happens is we have a problem plus a solution, which we call an algorithm, is equivalent to a program or an application, and this application solves a problem. Hope that is clear. So a problem is the mother of an application or a system. So for every system, for every program, for every application that you've encountered before that is within anywhere in any device in this world, exists because earlier there was a problem. So the whole concept of programming is about problem solving. But in the real world of programming, how do you begin to program? So since programming is problem solving, so we have a series of steps that we go through. Steps of problem solving. Okay, so one is identify the problem. Okay, identify the problem. After identifying the problem, there is a need for analysis of the problem. 3, develop a solution for the problem, and in that case we call that an algorithm. 4, actual coding, or what we call programming. So to someone who is very wise, you've already noticed that all along, even in the previous episode that we had actually started introducing ourselves to the 4th step of problem solving. but before it happens, quite a number of steps, which are 3 of them, really do happen before this 4th step occurs. So 5, we have what we call compilation and debugging. Then 6, we have what we call running and testing the application. Then 7, we have what we call documentation. Okay, be mindful about the spellings. The good idea is, as I speak, I'm typing, so mark the typing and mark the audio bit of it. Okay, so we need to identify the problem. You cannot solve a problem that you have not identified. Okay, so first identify the problem, realize what are you really looking at before you enter into the concept of programming. So in reality, first have a problem, know the problem, then think of a solution. Okay, for example, a certain school needs a school management system. A certain school needs a school management system. Okay, a certain telecom company like Airtel needs a mobile money application. Okay, a certain should we say a user or any kind of person interested in music needs a media player, or an organization needs a payroll management system. Okay, you know the problem. So after knowing the problem, there is need for analysis, and what happens under analysis is you'll need to identify the inputs, you'll need to identify the outputs, and you need to identify the mode of operation. For example, it is a payroll management system, okay, which means things like net pay can happen. You have a gross amount that is being given, then you have taxes. So what if I enter the gross pay within the system? That is an input. Output, I expect a net pay. I expect deductions basing on taxes. Then how is it going to do all that? Those are what we call modes of operation. Okay, so after knowing the problem, after analyzing the problem, of course, whatever I mention up here or whatever I mention in every episode is not a seal. Like, you don't have to search out for more info. I told you the best way to be a good programmer or a perfect programmer is to always make research, update your knowledge, know more, and make practice. Okay, practice is way to come in our future episodes. So develop a solution. A solution this time around is known as an algorithm, and algorithms are series of well-defined procedures. Which when executed means run, the problem is solved. Don't forget, we are looking at steps of problem solving. How do you get to develop an application? How do you get to develop a system? How do you get to develop a software? How do you get to begin programming? That is the question that we are trying to answer in this section. So we develop a solution which we refer to as an algorithm, but mark this, an algorithm is different from logarithms. Okay, so here we are dealing with algorithms. So a series of well-defined procedures which when executed executed, I said it also means run, a problem is solved. Okay, now whenever we talk about algorithms are represented in a number of ways. Algorithms are represented in a number of ways. One, by writing what we call pseudocodes. Two, by having what we call decision tables. These might be quite rare sometimes. Then three, having what we call flowcharts. Okay, so pseudocodes, to briefly talk about them, these are English-like statements that can easily be translated into a high-level language source code. Source code was talked about in our previous episode. Hopefully you made the research and you are at par. We talked about programming languages. I gave you a question about finding out the categories of programming languages, so I'm very sure you must have tapped into high-level language. So English-like statements that can easily be translated into a high-level language source code. Okay, now we have what we call decision tables. This is your first research in this episode. Flowcharts, these are symbolic representations of algorithms. Sorry about that. Symbolic representations of algorithms. Here we use quite a number of symbols like oval, like square, like rectangle, like the diamond symbol. Okay, so you can make more research about them and how they really represent those activities within algorithms. So we know the problem, we have made an analysis about the problem, we have a solution, or what we call an algorithm. Then finally, what shall we think about? We shall think about coding or programming. So maybe in this section I can try to give an example of an algorithm in form of a pseudocode. Okay, for example, we can have a question, write an algorithm for a program that will check if a given number is odd or even. Think about that. Okay, that is the problem. Okay, so here we need to identify the problem, trying to follow the steps. Problem is identifying even or odd. So how is it done? First we need to analyze. Since we know the problem, analysis, it means if you talk about inputs for the program, those are going to be numbers, definitely. Okay, then if we talk about output, definitely we shall have to tell even or odd. So it goes back to solving the problem. Okay, then mode of operation. Of course, if you know what even and odd numbers are, it means you'll consider the concept of divisible by 2 or not. So if it is divisible by 2, then it is an even number. If it is not divisible by 2, then it is an odd number. So what happens? We shall begin by developing a simple algorithm. Now, when we talk about pseudocodes, up here we are going to update our content. We use terms like start, we use terms like end, we use terms like print, we use terms like display. What else do we use? Start, end, print, display, repeat, so we have quite a number of terms or statements that we use, since we said it is English like. Okay, so back here, basing on that, of course I know someone is going to go deeper when they are so much interested in how to write algorithms. Of course, this can be got so much if someone is really doing what we call data structures and algorithms. So now, how shall we start this pseudocode? Now, when writing algorithms, we assume that it's gonna be a working program, and a program can never solve any problem unless if that program is in execution. So we shall start by saying start program. Okay, so we shall start by saying start program. So in the next bit we shall say set x to store numbers. Now, in actual execution of the program, or when we are having an imagination that this program is going to be under execution, to accept a number, then after accepting a number, it divides the number by 2, then it checks if there is a remainder or not. It means that number that it's going to accept, that number has to be stored somewhere within the program. So that is why we are using a command set or a statement set, and we are saying our location to keep the number is gonna be called x. So let's make x capital to make it more clear. So we shall say store, set x to store the number. So in the next bit we shall use a statement print. And what is print going to do? It's like an opening statement. We assume this statement will be printed on the screen so that the user gets to know what exactly the program will be doing. So the print statement will say enter number to tell if odd or even. I'm not saying this has to be specific. You can find any statement for as long as it carries meaning to what the program is doing. Okay, so what is going to happen? Capture number, we shall use an arrow, store in x. Definitely where the number has been typed by the user, we assume that that number has to be sent into x. Remember, x is our reserved location where the number has to be kept, and it will be picked from there later for use. So internally we shall allow to capture the number, then store in x. Definitely after, we shall say divide x by 2. Divide x by 2. We shall check if has a remainder. If has a remainder, go to step. Let's assume it will be our third step, or if no remainder, go to step 4. Okay, so what's gonna be in step 3? We are saying divide x by 2. If it has a remainder, go to step 3. So what will be in step 3? We shall command it to print the number is even, since no remainder. Otherwise, step 4, we shall still print a statement and say the number is odd. Okay. Finally, if a program has finished doing all that it has to do, of course it will have to end. Okay, so basically I was trying to show you how algorithms can look like. Of course, if you read around, if you go to the internet, if you check through a number of books, you realize people are writing algorithms in different ways, but this is one of the basic ways of writing an algorithm. So without forgetting, our question was write an algorithm of a program that will check if a number is odd or even. But how did we come to that? We started from a point whereby we are developing a solution, which we said a series or a set of well-defined procedures which, when executed, the problem is solved. Definitely, if you try to look at our algorithm at the end of it all, it can tell us if the number that the user had entered is even or it's odd. Okay, so that is how algorithms get to appear. Now back to step 4. Step 4 is actual coding. Actual coding involves the programmer choosing the tools to use in the activity. One, they need to choose a programming language. Okay, it's among the tools. 2, they will need to choose a compiler, or they will need to choose an interpreter. They will need to choose a debugger depending on what they are going to do. They will need to choose a text editor. They will need to choose an IDE. So depending on what the programmer is going to do, the kind of the problem they have, the nature of knowledge or the knowledge they have, so that one is a determinant, or they are all determinants of what tools they are going to use. So here, for our case, as we shall continue in the future, our target language is going to be C++. Okay, so that is what I had promised you earlier in the first episode, that we shall know the target or what we are going to be having in this journey. So for this case, our choice of tool is gonna be C++ as our programming language. Now, if there is need for a compiler, we shall first need to know what is a compiler. It's also a software, by the way. It's a software, so it means there is a programmer or a certain group of programmers that sat and thought of a problem. Sat and thought that there was a problem and they needed to have an application that is called a compiler. So right now we need to know what is a compiler. A software that translates source code. We know the definition by now if you had made the research. That translates the source code from high-level language to low-level language. Okay, now examples of compilers. I'm going to be specific, basing on the language that we are going to use, and that is our C++. So we have what we call digital math. Then we have what we call dev C++. Then we have what we call code blocks. Then we have by the way, we have quite a number. we have quite a number. We have C-free, and for your information, most of these are free on the market. You just go to Google, okay, you just command to download. Of course, you'll have the application and install. So we shall come back to that when the time is right, but basically software that translates source code from high level to low level. Now, why are we talking about translating? The reason is simple. One thing that you need to know is that whatever you're doing, the computer does not understand. Whatever you're doing, the CPU, or what you guys call the brain of the computer, or the central processing unit, does not understand. So along the way, it will need a version of what you've written, you as the programmer, okay, a version that it can understand from what you've written. So the only way you can arrive to that is by having a compiler. So your source code, assume it is in C++, then it needs to go to the form that the CPU can understand. So what handles the donkey work in between? That is gonna be the compiler, and we have a series of compilers, okay? So that is why we shall need a compiler, and the process is called compilation. The process is called compilation. So if you hear anybody saying please compile the application, please compile the program, it means they're asking you to translate from high level to low level. Low level, sometimes it means binary or object code, the form or the version that the CPU can understand and process to a meaningful state so that you get what you expect. So here we go. Then we have the compiler. By the way, the compiler almost does the same, but for it handles line per line, in the source code. So if it's conversion from high level to low level, it does it bit per bit in terms of lines. Then we have a debugger. This one allows to trace for errors. Errors in this case are called bugs, okay? Allows you to trace for errors and remove them. Who removes them? It is not the debugger, it is you, the programmer. And where we are going, you're going to realize that one of the hardest tasks of every programmer is to locate errors, but we shall get there, don't worry. Then we have what we call text editors. The way they sound allow us to write source code, just source code in most cases. So if you want the text editor to do for you more, then you'll need to have certain other kinds of integrations if at all the text editor is configured to do so, or if it was designed to have such a capability. So text editors allow you to write source code, but one thing that you should not forget is that when you talk about compilers, some of these compilers come when they have inbuilt text editors. For example, CodeBlocks does, C-free does, Dev C++ does, or Bloodshed Dev, whatever it is, it has a text editor. But a compiler like Digital Mars, it never has a text editor. So it means if you're using a compiler like Digital Mars, you'll need to have the compiler separate, and you need to have a text editor that will allow you write your code. Other compilers that come with the text editors, it means you write in the text editor and you compile from there at the same time. So sometimes someone will need the text editor, sometimes they won't, but depending. But that doesn't deny us from talking about them. So What do text editors do? They allow you to write the source code. Okay, examples of text editors, these ones can also be got without any cost or payment. You just go to Google and download. So we have one that is so cute, which is called Sublime. Actually, it's the one that I'm using right now. If you can look up here, we have what we call Sublime, we have what we call VS Code. Okay, if you want, we can have an interaction here. It looks like this, Visual Studio Code. So when you see that icon, then automatically you're handling that text editor. But for it, VS Code is given the capability to configure and add in third-party tools like compilers to allow you handle several languages. So we have VS Code, we have Sublime, we have Atom, we have Notepad++, and quite a number. So doesn't do any harm if you only have one, or if you have all of them on your piece. Of course, along the way, when you begin using each one of them, you realize which one is better than the other, which one is more comfortable to you as the programmer. You know, different programmers always have different comfort based on the tools they choose. Don't forget, we are still under step 4 of problem solving, actual coding. How did we get into all this? We said when this step has to occur, it means the programmer has to choose the tools that they are going to use. But what determines the tools to use? It's the technology of programming that you're going to be using. It is your knowledge that you have, because your knowledge might dictate that I would want to use a certain kind of tool. So for our case, we said our target is going to be C++, and in the future episodes we shall see how that can really be handled. Then we have what we call an IDE as one of the tools that we can have in programming. IDE means integrative development environment. Okay, and these are also quite many. One of them we have is Visual Studio, a product of Microsoft. Studio, it's a huge application. Of course, when someone says integrative or IDE means it's a single application, right? And this application is having quite a number of tools, those that you need at that particular moment and those that you might need in the future. So it has a number, right? Like it has quite a number of tools. That is why it's called integrative. So when you open the tool and you're using the tool, you only use what you feel you want. It's like having a buffet meal. Like, I'll have this, I don't like that, I don't like this, I'll use this. So that is how an IDE tool looks like. So among them we have what we call Visual Studio. Actually, I have one on my machine for other programming purposes. The version is 2019, the one that I have, but of course you can look out for another version if at all need arises. Then another one is called NetBeans. It's also an IDE. Then we have another one which is called Eclipse. So there are quite a number. So NetBeans, it also looks like this. I'll not open, but I can show you how the icon really looks like. So that is an IDE. I think you already see the word there. So it's also an IDE. So for cases where you prefer having IDEs, then you have quite a number of examples to pick from. Again, Google can always provide you with a number of names for more comfortable and more new IDE tools. Step 5, compilation. We've talked about that. Then we have what we call debugging. We said it's about removing it's about allocating, it's about locating errors in the program and remove them. This is one of the hardest tasks of every programmer. You may realize that writing source code is quite simple. I won't say it is really that simple, but again, removing the errors is another task. But no worry, a journey of 1,000 miles begins with a single step. But definitely we need to talk about errors. So we use a debugger, like we said up there. The debugger will help you find the error if possible, though not all errors can be located by the debugger. Some errors have to be located by the programmer, but we shall get into that. So types of errors. One, we have what we call syntactical errors. Syntactical, or sometimes we call it syntax errors. Then two, we have those that are known as logical errors. We have those that are known as runtime errors, and we have those that are known as compile time errors. I might not endeavor to talk about each of them in details, but at least I'm going to give you a glimpse of a few among them. So syntactical errors, what we call syntax errors. Now, for every programming language, I think we know what we call a language. For every programming language, there are two features. Every programming languages, there are two features of programming languages. One, we have what we call syntax. Two, we have what we call semantics. Never know, there might be more features, but for this case, for me to exhaust the concept of syntactical errors, I'll need to talk about these two. So the features, we have syntax. Now, for any language, let it be natural languages or programming languages, there are what we call rules or grammar. Okay, there are what we call rules or grammar. So in programming, that is called syntax. So the rules that guide or govern a specific programming language, those rules are called syntax. Okay, now violation of the rules causes syntax errors. Very simple to understand. You have the rules, you have the grammar. So violation of the grammar, what happens? Of course, you're going to get errors, and those types of errors are the ones that we know as syntax errors. The language says this, you forget to do it. The language says that, you choose to do something else. Actually, we are going to be facing some of those errors, and they are the most encountered errors to programmers. Even if you are an expert or you're a novice programmer, we are always prone to errors, any type of error, but these are the most encountered errors: syntax errors, violation of rules or violation of grammar for that specific programming language. Now, semantics is about the understanding. This is quite tricky sometimes. The understanding or the interpretation of programming statements. This is so interesting. Why? Because in the real life, the way we interpret certain spoken statements is not the same way it's done in programming. So the interpretation of a programming statement, in its correct or wrong interpretation, definitely that is what we call semantics. So if it's wrongly interpreted, then wrong semantics. If it is right interpreted, then that is correct semantics. So basically the difference between syntax and semantics has been already spotted out. Okay, we shall encounter that in the practical world as we go along in the other future episodes. Then we have what we call logical, the way it sounds. It plays with the mind, it plays with the flow and the operation of the program. But what happens? The program is executing. The program is running, but giving unexpected results. Think about it. Compiler says, me, I'm fine. Everything says, I'm fine. But running the program, you're getting wrong results. Okay, those are known as logical errors. How do they occur? Poor logical organization or flow of program execution. Now, this is all done by the mind of a programmer, because every line of code that you write is definitely the way you think. So joined with semantics, you're most likely to get logical errors. The way you think about a statement, the way you think it's logically interpreted, at the end of the day, things might not really go well. The program is working, but not perfect, but not as expected. Runtime, guys, you look out for that. Then compile time errors, I'll be glad coming back in the next episode when you guys have really found about that. Then running and testing. Okay, now running and testing, of course, we have types of executing applications that you've already written. Remember where we came from? We got the problem, we analyzed the problem, we developed the solution, we did compilation and debugging. So quite a number of steps that we went through. Now there is a moment you have the program and you want to run it. Okay, so we have forms of running or executing. We have what we call the actual run. Then 2, we have what we call the dry run, and this is the weapon of every mind of a programmer. Dry running. We have a saying: if you manage to write it, if you manage to source code, then it is as good as saying you can execute the program by head without a PC and make sure it entirely functions as expected. We use the computer. We use the computer with already verified data and results. What do I mean? I'm developing a payroll management system, but in my calculation, if an employee is receiving 1 million as salary, that is gross pay, then I expect the net pay to be maybe 750,000. Now I've done that, I've tested it on paper, so I know when I enter 1M I'm getting 750,000. Then in the actual run, you test it and see if the program is really giving you 750,000. So dry run, here we use the ability of the mind. Okay, ability of the mind, as we test every line bit per bit, while following the logical flow of the application. Okay, reason to confirm. Okay, to confirm if the application is executing as expected. Okay, as expected. You are using the mind. It's called the programmer's mind. Now, in most cases, the way you execute the program using your mind, definitely that is how the computer is going to do it. So we use what we call a dry run, and we use what we call an actual run. So once again, my name is Ismail Serunjoji, aka Programmer's Life. Okay, for more details, reach out on Programmer's Life at gmail.com. Then if you want to chat with me on WhatsApp, then that is 751-824973. Have a good evening.